Hello and welcome to our webinar. This is a path towards an integrated digital environment showcasing Prostep's platform for enterprise collaboration and customer delivery. My name is Brian Scouten. I'm Director of Technical Pre-Sales at Prostep Incorporated. Today we'll be taking you through Prostep's digital thread platform for an IDE in aerospace and defense. This is going to include Prostep's platform for an IDE that encompasses different products supporting an integrated digital thread and digital twin, including collaboration with suppliers and partners. This is a MOSA-compliant integrated digital environment, Prostep focusing on standards and practices within engineering and manufacturing domains in order to have that type of interoperability. Our agenda for today is going to start with who is Prostep as a neutral vendor using open standards and focus on interoperability to provide these types of solutions. Then go into the digital thread platform provided by Prostep for the overall IDE solution. This is going to give you that vision of what our IDE solution is all about, and then dive into the different components of that. OpenCLM, providing that digital thread and traceability for configuration lifecycle management of the different domains, and gluing that all together. OpenPDM, providing the connectivity as well as synchronization of data between different environments and also migration of data if necessary between different tools. OpenDXM GlobalX, collaboration platform, providing secure integrated data exchange, but also easy ways in order to have off-the-shelf components, generate digital data packages, technical data packages, integrate with PLM in order to bring data out into your partners and suppliers and OEMs, and also bring data back from them and then integrate it back into your systems. And then finally, next steps and how you can engage and try and build out your integrated digital environment yourself. So we'll start with a little bit about Prostep. Prostep was founded over 30 years ago in 1993. This was out of a consortium of automotive organizations working in different vendor-supplied systems at the time that needed a way to exchange and make data more interoperable. So you see at the bottom, there's different automotive OEM and tier ones. These are our owners of Prostep, as well as the Prostep IVIP Association in the lower left. It's a nonprofit standards body that focuses on creating standards and best practices for interoperability of engineering and manufacturing data. The Prostep IVIP Association, also started over 30 years ago, was initially focused on automotive data exchange, and so came up with the 10303 AP214 automotive data exchange that merged the geometry data with PLM data to make things more interoperable between those automotive customers and suppliers. Since then, there's been a wide variety of expansion into other domains. So that could be step 242, and then the standard through ISO of that, as well as the maintenance of that with edition 2. But then REC-IF and requirements interoperability, digital data packages, JT as an ISO standard, and other types of standards, to try and promote interoperability, from systems engineering to manufacturing data and beyond. Something that makes Prostep unique as a vendor within this space is our partnerships and our neutrality. So we bring together the technical partnerships to enable our products, to license the APIs that are needed in order to integrate with the different systems, to promote our connectors for those systems. But then also to work with those companies to get what the best practices for our integration are, and to get the next release so we can support these types of products long term. So you see a wide variety of different vendors here that we partnered with, including the major players like Dassault Systems and Siemens, PTC, SAP, Oracle, and others, as well as some within the shipbuilding industry, some within analysis and simulation, and ERP, MES, and others. Let's dig into the IDE solution for aerospace and defense. So let's introduce the Prostep digital thread platform. This consists of the 3 different products that Prostep offers: OpenPDM that enables the federation and synchronization of data, OpenDXM GlobalX that enables collaboration with your partners and suppliers. OpenCLM provides traceability of the different systems and artifacts within those systems to provide configuration and lifecycle management. So overall, a couple of founding theories behind this is to enable you to have your data more interoperable, right? To enable your data to live within the repositories and have the authoritative source of truth in your existing systems, and not be migrating and trying to create a super system that encompasses all data, but leveraging the best in breed that you already have available today in order to create a digital thread platform and an IDE that suits your organization without retraining users and adopting new systems and things of that nature. Core to this is that application data layer. We have connectors that can then enable import, export, and linking data into all these different systems that are at the bottom, that then our products can use the services to and provide that kind of connected layer. The foundation of the Prostep digital platform is your existing enterprise. And you see at the bottom here, we've got that application data, including the different systems that you're using in order to manage that data. So typically we don't deal with the clients that are authoring that, but we want to focus on the authoritative source of truth that are within those different repositories that are statused and collaborated on through the authors in order to come up with what that data is. Above that, Prostep provides that data provision and access layer with our connectors. So this is really the magic behind the system, is all the connectors work with the backend system to read and write data, but above that provide the same interface with the same data model to enable a lot of flexibility and be able to have all the tools above that within the processing layer that can do the different orchestration or mapping of data or processing of data, collaboration of data, and do that within the different portals that we have, including our OpenPDM for interoperability and synchronization, migration of data, OpenDXM GlobalX for collaboration, and OpenCLM to provide that traceability. The vision for the Prostep integrated digital environment is to first provide the connectivity and local processing services across your divisions or different domains, or maybe isolated data within the programs that you have, and have the connectors there have local processing services like transformation services for data at the source so that it can more efficiently process data, and then build that standard connector interface and service interface to provide data to the different products. So provide data to OpenDXM GlobalX so that you can collaborate with your partners, and that could generate data packages from multiple sources, and then put those together so that exchange data or bring data from collaboration partners, and then bring it back into those different systems. Provide traceability with OpenCLM through that portal to glue together and configuration manage the different data over different divisions or different domains so that you can trace data across these different systems without ripping and replacing the data or the system. And finally, OpenPDM with the workflow engine and the ability in order to drive data between different systems for synchronization of data. So the core value of this and this approach is that, number one, it's entirely transactional. Number two, we're not ripping and replacing any of these systems. So we're adding business value without consolidating into a new data lake or a new system itself that wants to be the owner of all this data in the future. And we think that's all value add, right? So we're just trying to use the existing business solutions that you have, that your users know how to use, that's really the best in breed for your organization today. And we're flexible about the adoption of this as well. So you can start with 2 or 3 systems and then get those processes running. You can maintain them system by system. So if you've got an upgrade within one of your PLMs, we'll provide you a new connector, and it's independent of the whole system. So kind of building that hub and spoke architecture, and doing that without ripping and replacing or needing to train existing users or use a different system. The core tenet to Prostep is being open, and that's why our products are named OpenPDM, OpenDXM GlobalX, OpenCLM. We want to enable the customer to do anything within our product that we can do internally, and not hide APIs or have something that's only something that's proprietary. And that's because interoperability is really within the DNA of Prostep, and that lends itself perfectly to a modular open systems approach, or MOSA. And we think this can give you a competitive advantage to your next proposal. With the tenets of MOSA and establishing this enabling environment, we can provide some of that automation that can promote your agile practices and continuous integration services and CI/CD pipelines. We have that modular architecture and design. Our services and components are microservices based. They're distributed and flexible so that you can have the parallelization and failover and other things of that nature. And that can also then enable your other systems to be modular as well, to provide those services through that connectivity that we're offering. You have those published APIs that come with our integration interfaces that then also enable you to use these integrations effectively with an open system approach. Standards, we are Prostep, so it's in our culture, and we also promote not just STEP standards, but all types of engineering and manufacturing interoperability standards, including trying to bring together all those standards in like digital data packages. And through all this, you can then certify a higher percentage score, and then you can pass that on to your customer within your proposals, again, giving you that competitive advantage. With Prostep's vision for the IDE kind of set, I want to dig in a little bit deeper into the three different tools that are supporting that. First is OpenCLM, used for integrated enterprise traceability. OpenCLM was created to solve the challenge of having distributed data within different repositories and the need to create a digital thread between those. So you could have requirements data or regulations and compliance data or systems engineering data or after sales and sustainment data or PLM data, ALM data, software data, ECAD, MCAD data, trying to bridge all those different repositories of information. And those might have just distributed information that aren't bound together. They don't have good documentation, especially for regulation or sustainment. And they might not have clear maturity states. This is where the CLM, the configuration lifecycle management, comes into play. To create a vision of all the configured data and the maturity states across these systems with that type of data. And it might not be interoperable or have an efficient way to package the data together. So OpenCLM provides that cross-domain, cross-division management and process. OpenCLM provides that process is by building linked data sets and digital thread from configuration items within OpenCLM to the systems that are outside there. So if you wanted to then say, I want to understand the impact of a requirements change on my mechanical CAD or software or regulations or other data, then you can then go into OpenCLM, see where the impacts are between the different data sets, and perform that type of impact analysis. It provides that orchestration across all those different repositories to create that contiguous digital thread, across the different domain repositories. And kind of bring together a configuration lifecycle management system that can create baselines and understand the maturity states of the data within the different systems so that you can ensure that all the data is up to date and has also standards-based interoperability and cross-domain type of collaboration. So OpenCLM's architecture is very modern. Starting, with the application itself is microservices based. Using a Spring framework. It has a MongoDB backend. It's used for database, and then also a GraphQL reporting engine. So you can get all sorts of great reports out of that system, really anything within that database to be able to publish and use for other applications. So if you're consuming that data, within, business systems, even AI type systems, you can do that through those interfaces. It also has adapters for OSLC to use as a consumer. So if you have an OSLC enabled system, you can read data from there, as well as the OpenPDM and connectors, having that standard-based interface to the backend systems like MES or PLM, ALM, requirement systems, other things like that. It uses Keycloak and OpenID so that you can provide identity provision and SSO for OpenCLM itself, and then also through the connectors to the backend as well. So let's show a brief OpenCLM demo. We're going to start by, as a user, logging into the system. You've got different roles within OpenCLM, including, administrative roles, roles as, project managers, as well as others. So if you're a project manager, you might have many projects and many tasks that you might have created here. You see on the left-hand side, you've got a list of different tasks that were created. projects in the middle, and then configuration items that you own on the right-hand side. Many of the projects within this OpenCLM system are actually the Mars rover data. So Prostep has a JPL Mars rover Raspberry Pi powered data set that they're using within a lot of different systems in order to showcase interoperability. So on the upper right, we see that Marcus Erickson has asked that we complete a simulation task to ensure that all the results are satisfactory. Then we can go ahead and approve that task. So we can then just click on it and jump into it. You see that once you're in the project, you've got a navigation tab on the left-hand side that enables a tree, right, where you can see the different parts of a process that you can even install as a template in order to have a kind of a default process. But then, once you have that selected, it shows a graph of all the dependencies on the right-hand side. So there in the middle, you see the simulation of change systems, and you see that it's not blue like the other systems might be, but it says in review, and we want to go ahead and make sure that all the dependencies of those are checked to make sure that the systems that have those artifacts are validated, and then we can go ahead and within OpenCLM take that from review and then publish it. And when that's published, also create a baseline of all that data together so that can be tracked comprehensively. So we start and we can go to some of our software artifacts. We can click through to data that has actually been linked to OpenCLM. First within the CodeBeamer application with some software data. Now we can see that this bogey assembly for the Mars rover and the mechanical design within Windchill, as well as other systems. So these have already been established through kind of a search and select procedure from OpenCLM into these other systems. We can also go take a look a little bit at the result here, and you see that we've got an artifact that's got a file on it within GitLab. So you can go ahead and from OpenCLM also select to just download the data directly and then open it up from there. And this, in fact, goes to the backend system. It needs to authenticate against there, and then goes and enables you to be able to download those files, like you would from GitLab natively. From this, you can also see that there's a where used analysis, an impact analysis, and also impacting entities. And we can go ahead and select that in order to expand what that graph looks like to show all the different impacting entities. Within this graph view, you also at the top have a filter, and you can filter out different types of relationships. You can filter out different types of objects that you would want to see within there. And then also, maybe just click, in this case, max depth, and then it will explode the graph so that it shows all the dependencies down the tree. So you see that there's some that are product structure, there's some model ones, some software ones. They've got design specifications and documents that are associated to that. But then further down from there, if we do expand this, then you'll see others, right? There's going to be requirements, and other specification documents that then drive, what those decisions really are that have been made within this OpenCLM dependency graph, right? So from here you can actually see, more work and a decomposition of this. Where you might have the chassis itself, but the chassis is made up of components like the assembly, the wheel assembly, the organic chassis, and current chassis. And that's derived from requirements that have been actually put within other systems as well. So you see that, there's requirements down below maybe from Jira, or maybe requirements from Doors NG as well. Things like weight, load, and insurance that it's robust, things like that. This is, in fact, from Doors associated through OSLC. You can see it's mapped in some attributes from the integration, so you can get the descriptions and text and other things that you might want mapped in, as well as things like a weight, into OpenCLM itself. And then you can see on the other side, there's other software and requirements that are driving that software as well, and issues. So you can see the different requirements. Those might be coming from a different system. So select that, and you see that the steep terrain requirement is coming from a Jira system. And you have other types of attributes that have been mapped in to OpenCLM from that Jira system. And you can also click through in order to go and jump into Jira, so you can see that requirement itself as well, and click through to the different artifacts there. Yeah, so with that, then you've looked through the different components of your simulation that's changed, and you're ready to go ahead and change it. So you can go ahead and select approve or reject if you didn't find it satisfactory, and create that baseline within the system here, so that you're ready to move forward. So OpenCLM has many benefits, including that configurable process that you saw in the tree there, that you can use then to drive through that template and create the workflow for making sure that you have all the different dependencies checked for a specific task, and then provide the links to the backend data, that digital thread, for those dependencies. Those digital threads using out-of-the-box connectors or standardized OSLC adapters, and then also has the API of those backend systems to ensure that you're respecting the credentials of that system and the access control list of that system as well on the back end, as well as within OpenCLM. So this enables you to orchestrate data more efficiently, create traceability across domains, create traceability across divisions, and then you can use the GraphQL and other databases or direct to database in order to pull data out of OpenCLM if you need to create very robust reports. And it has a modern architecture that's very extensible. So now that we've gone through OpenCLM, we're going to dig a little deeper into OpenPDM as a product, as well as the connector technology that really supports OpenCLM, OpenDXM GlobalX, and the OpenPDM integration suite. OpenPDM itself has different engagement levels. The one that's focused on IDE is really the one on the left, the OpenPDM Integrate. This is a fully flexible solution that enables any amount of off-the-shelf connectors, with processes that could be internal or external to your organization, and really full-fledged connectivity. We also offer OpenPDM Migrate. That's a specialized tool that utilizes integration connectors, but also has specialized high-performance connectors that use migration APIs, as well as staging databases for an ETL style load, tools for data evaluation, reporting, cleanup, validation, and really a process as well that goes along with migration to drive you through the migration process. And that's sometimes not sold as a perpetual license, but rented because it may be a temporary thing. We also have OpenPDM Collaborate that's intended to be a neutral PLM itself, or a bridge between different partners to have a PLM for something like an aerospace program or a joint venture or something like that. And this includes the ability to do some IP filtering to bring just what's necessary from your PLM into that neutral PLM or exchange between different partners, as well as the ability to do a delta synchronization in order to really try and tune the performance down to what just needs to be synchronized for that interval, because a lot of times this is a massive amount of data that might be shared between. So these OpenPDM connectors really power the vision for interoperability with all the different Prostep products within the digital thread platform. These connectors on the outside, speak the language of the native API of the system that it's connected to. But inside, in OpenPDM, on the OpenPDM interface side, has a standardized informational computational model that can really query to get very fine granular object and relationship and kind of a graph structure, and then can read and write data, has some default out-of-the-box configuration, and is modular so that it can be upgraded independently from the rest of the system. So let's say you have a PLM that's going through an upgrade process. OpenPDM can give you a new connector for the new PLM, plug it in, run the regression testing, and get you on your way. The connectors always use the official system vendor API. This is why we have our technological partnerships in order to enable that type of interface and have that supported. They're compliant with system customization. So if you're creating soft types and adding attributes and doing things like that within your system, the connectors should work with those as well. And it uses that API and respects authentication and access control layers that maybe going direct to the database would not respect. And then we also have just what we call our connector template that we can use in case we don't support your system in order to implement quickly a OpenPDM compliant connector for your legacy system or a system that we just don't support yet. You see on the right-hand side a variety of different connectors. So we support a wide variety of PDM and PLM, including Teamcenter, Windchill, 3DX, SmartTeam, Aris, and others, Arena. On the ALM side, Codebeamer, Jira, Polarian, NoMagic, that's a Teamwork Cloud connector, and others as well. You see that there's some data exchange, Primavera, ERP connections, mainly with SAP, but others as well, IoT connections, and then a variety of services on the left-hand side, including a step toolkit that we use in order to create late binding, early binding of step data. That's not geometry data per se, but other PLM data or other types of engineering data that we can then put together in a step format. Or expose those web services in a RESTful API, have a OSLC provider, and that's our OSLC adapter that we can then put against any of the connectors to make them an OSLC compliant provider, an OAGIS that's used for MES mapping or other XML mapping. So a wide variety of interoperability in order to make sure that you've got the services you need in order to integrate your data and collaborate with your partners. With OpenPDM 9, that's about 3 years old now, we moved to a microservices architecture. So most of these applications run on Tomcat that then is bundled and is a microservice. So you can, load them on Docker, Kubernetes, OpenShift, things like that. They have standardized RESTful interfaces that they can communicate with each other. And then, with that microservices architecture enables scalability, failover, fault tolerance, very distributed models so that you can keep these connectors close to the application, which is important for, performance constraints. Depending on the speed and performance of the APIs of those backend systems. We have a registry service that then we can use in order to see, what's available, within the ecosystem. And they all share the OUCA, or OpenPDM Unified Component Architecture, which is that common stack with common services, so that it enables you to have that backbone to have communication between all the components. So a simple process within OpenPDM using the OpenPDM process engine maybe looks like something like this, where you have 3D experience on the left-hand side, you've got SAP on the right-hand side, and you want to have a process that then communicates the data from 3D experience to SAP. So with the process engine within OpenPDM, and this is a BPMN compliant workflow engine based on Camunda that's bundled within the OpenPDM process server, we can then have a trigger that then starts this process. So in 3D experience, maybe that's a change action that's released that can then go in the middle of OpenPDM, instantiate that process that then works through that workflow in order to export the data. Maybe it looks at the change action and then all the problem and solution relationships to understand what needs to be exported, then maps the data to an SAP type of format, and then imports the data. So once it's mapped to materials or other things, routings, whatever might be required there, then you can import that data into the SAP environment, and finally it's made available there. OpenPDM has also a process cockpit so that you can monitor all these activities. It's very granular, so you can see each process, all the steps within the process, and then the intermediate transactional files and logs as well. So if you had mapping that goes from one system to another, then it'll show the different mappings, and then you can display those to make sure you can have the right data within that environment. It does not persist any of the data, in a neutral database or anything like that. Really, it's only the transactional data that you can then configure to be cleaned up that's within the OpenPDM process server itself. So let's dig in a little bit and show the OpenPDM discovery service. This is the registry service here. In this registry, you can see that we have a wide variety of connectors and services that are there. Some of them have some load on them, and some of them don't, right? So we can jump into the Team Center connector, detail some configurations. So you can see kind of a common configuration of a connector. You can validate to make sure that the connector is running, which is fed back to the registry as well. Do some rudimentary mapping here, so you can see that there's a business object type. You can map searches to Team Center searches in this case, and then have default export and import configurations so that if you provide it a data set, it already knows how to structure it and how to import it. The connectors also have a bundled query client with them. Within the query client, you can then go ahead and use the connector and query for data. So in this case, we're going to query for item revisions within the Team Center system, and then open up this DW0001 item revision. From within there, you see the standard things. There's a data set, a master form, the BOM view revision object as well. And then that BOM view has children, right, that go to other item revisions. And so that's kind of the data model of Team Center abstracted into our internal business object and relationship model. So now, just to show kind of something similar, we're going to jump into Windchill and show you that same business object and relationship model, but configured for Windchill. And you can see that we've already added some subtypes and attributes there, depending on what the Windchill configuration would be. We can go ahead and query for the same data that we've imported to Windchill, and you see here that we have a part structure of DW001. That's quite a lot like the item revision structure, but it's in a Windchill format. So the power of this interoperability is between these systems, because you have everything very much simplified to an object and relational model, you can easily then map data between the different systems or consume them, within other processes. I can consume the objects within OpenCLM. I can query for them like that, or other processes as well. So within OpenPDM, there's also this Camunda cockpit in the process server. The process server is that BPMN2 compliant workflow engine that you can maintain your processes in. In this case, we see that there was an error within one of the test processes, so we can go ahead and take a look at it. So if you're an administrator and there's an error, you might get an email of an issue. Then you can go into this interface and then see that, oh, the connector service was down. So it wasn't able to provide, the process. Or you can go in and take a look at, the results of a working process. So in this case, our Mars rover was sent from Windchill and then put in the Team Center. So you see that it was exported. There was let's compute the delta, and then do some mapping, and then do an import. And you can take a look at the different data that's part of the process, including the import data sets, maybe that are part of Windchill. Or you can look at, in a graphical way, that data as well. So we're saying that you can do all these things, yourself. All these different components are all bundled with a Swagger documentation interface that you can then test out and run the queries that you want to see maybe against the system within here to provide your own application integration if you need to. And this is part of being open with the OpenPDM integration, is enabling you with the connector API to use the services there. So along with those RESTful services that we saw within the Swagger documentation, we also have, like I mentioned before, an OSLC adapter. So you have that standardized computational interface with any OpenPDM connector. And what we've done is created an OSLC kind of bridge mapping between that standardized interface and OSLC that enables you to then query any different connector that OpenPDM supports as an OSLC compliant interface. So if you wanted to then federate data to something that is OSLC compliant, like it has a OSLC consumer, then you can plug that in, and it's an off-the-shelf way that you can make any of these different systems OSLC compliant, and then also configure them, to work in the way that you would want them to work, not within a limitation that might be provided by the native OSLC interface. So now that we've talked about the first two components to the Prostep digital thread platform, OpenCLM and OpenPDM, as well as the connectivity that we have with the connectors, and we're going to talk now about OpenDXM GlobalX and how to automate collaboration with your suppliers and customers. OpenDXM GlobalX at its core is a managed file transfer process. So that enables you to then provide a secure interface for sending data to customers or receiving data from customers or suppliers, and integrate that data into your existing systems. So it provides a wide amount of security. There's a lot of flexibility and scalability to the architecture, so you can distribute it, so you don't have to move files around your enterprise in order to have them sent out. Compliant, right, with extensive reporting and security. And then also it's a product that's been around for a while. It's got about 500,000 users, been around for over 30 years, and has definitely from that experience, grown into a very robust product suite for collaboration. So OpenDXM GlobalX has a variety of different integration points and client applications. So Outlook being a big one, this is how most people send files and could be a very gaping security hole where you can filter it so that all the files need to go through GlobalX. It also has Windows Explorer integration, like a Dropbox-like functionality. You can right-click and send to, or the standard browser functionality, so you can log in, from within your organization or from an external organization, authenticate, and then you can take a look at what's been provided to your web space, so you can download it or upload it to other web spaces. But really the core power within OpenDXM GlobalX is in the PDM integration. So this is where a user from within a PDM doesn't need to leave there. They can stay, they can create a transfer package, they can select the recipient, which then has behind the scenes kind of that recipe for any different types of translation or quality checks or data needs that the customer, the recipient might have. But then you can then go ahead and associate, what data you want to send from within the PDM, and then click go, and then all the process of exporting it, transforming it, and all those things that you might manually do in a swivel chair type of process today are all automated. And then it gets delivered, or an email maybe gets sent to the customer so they can come and authenticate and then maybe download that, depending on what type of integration they have with you. So very robust, and that also happens on the way back. So a customer can, from even the web browser, drop it into a web space, the data they send to you, and you can automate the process of opening that data up, evaluating it, and importing it directly within your PLM as well. We also offer a robot, gateway, and blockchain and other APIs. So these are automations and integrations that you can then use with GlobalX. We have a sample integration that's specific for 3D printing licenses for instances of prints that's blockchain enabled. We have a direct CAD integration that you can send data specifically directly from a CAD. And then also an embedded wizard that you can use in order to embed into other applications. So depending on what your needs are, you can use this frame for then, integrating into other interfaces depending on what your needs are at your enterprise. So the GlobalX PDM integration enables a user to work within their PDM system. So starting there, you can select documents and CAD structures or bills of material, parts, things like that. And then you can select the receiver within the PDM wizard, filter that data, do some check and analysis of that data depending on the recipient, and then click send at that point in time. And then the process is automated, and behind the scenes, that export action will use the API that's necessary in order to get the data. So in some cases, that might be a CAD API that you can use with a conjunction of a PLM and a CAD system, like Team Center integration for CATIA, or the Windshield Workgroup Manager, or the XPDM export interface, downsave CATIA V5 from 3DX, things like that. And we can automate all those processes, as well as then do conversion from there and quality checks and renaming. So your internal identification might not be what the customer or supplier has named it, and then you can go ahead and transform the CAD to have the right names. You then put that into a technical data package that might include XML, STEP, or a digital data package, or a technical data package like a MilSpec 31000, 3D PDF, or other things, and then send that container to the partner. The partner then can go ahead and process the data offline, but then bring that data back in and bring that container with the data back in. And then OpenDXM GlobalX can then process that data, name it back to what your conventions are, do quality checks. It could reject the data if it doesn't find that it has the right validation, and say, no, we want you to correct these things before we are going to process them. It'll go ahead and analyze the differences between what's in the PLM system, and then create and upload that package. It can upload it just as effectively documents as a zip, yeah, but it could also explode it and upload it and understand the import strategy of what has been revised and what has been updated, what's been removed from the BOM, what's been added to the BOM, things like that, in order to make sure that there's a real comprehensive import action. And that depends on your level of comfort with customers too. Sometimes that has a lot of rules that need to be defined in order to then process that. And then get the data back into your PLM system so your user that's working with that data never leaves that system. That it gets sent out from there and then gets brought back to that system so they can use it from the supplier or customer. So an example of this process is our Mars rover, again, modeled within Windchill. So you see that we've got that chassis component there, the bogie assembly. And we're going to go ahead and send that data out for change. So we can go and take a look, and we can see that we've got our bogie stability change. We want to go ahead and send that to the supplier of that, so that then they can do the evaluation and any of the updates. So taking a look, we can create a container, OpenDXM GlobalX folder, and name that, and then create a short description, and then with that container, add the data to it so that we have within the PLM system a history of what that transaction is. And that transaction itself then also can have status on it, like it's been sent out, or it's been completed, or it's in the process of being sent, things like that. And then you can go ahead and start the wizard, selecting the data that you want to send. You can filter the data. You can send the data for different purposes. So if it's sent for modification, it's going to expect that that data set, when sent back, then is going to be directly re-imported into the PLM, and not as like a zip or something like that. So we've selected Susan Wong as the recipient. And so the profile for Susan Wong will then be used in order to translate the data. In this case, it's just going to be exported through JLink and the Creo interface, as well as the metadata from the connector. You can filter and add other types of data as well. So if you've got documents that might be connected to the product structure, or other types of files and data, or metadata that's associated with it, you can bring that data in. It'll go ahead and create the check and then send that data out. And with that, it's complete and it will be sent to the recipient. The recipient then can log in to the web interface, or if there's an automated process, can then receive the data that way. So both OpenDXM GlobalX and OpenPDM use what's called the batch processing framework in order to do that quality check and analysis or transformation. And this is a distributed framework that's actually based on Python that enable you to do some easy scripting within there, but then has a workflow that then can be distributed to other servers depending on the load that's incorporated with that workflow. We also have an existing catalog of other processes. So many of these are taking data from a native format like Creo, CATIA NX to and from STEP or SolidWorks, or doing quality check or VALDAT or model check or other things like that. And we have others as well that are associated with that. So transformation processes, quality check and analysis processes, renaming type of processes, that are within this catalog. And then we could also, with this framework, then embed, the best in breed, transformation tool that you already use that you might have agreed to with your customer. So if you're, trying to go from one CAD format to another, and you've got a tool from another vendor that you're going to use, we can put that within this framework, and then use that tool in order to do these types of processes and get the results that you need. Finally, now that we've gone through our vision for the IDE, explained our digital thread platform and the different components with OpenPDM, OpenCLM, and OpenDXM GlobalX, we want to invite you to reach out to us. So we are here to help. We've been doing this for a while, over 30 years. We've got hundreds of consultants that work on these projects all the time. And then also the standards-based background in order to support that. So please feel free to reach out to me or to Prostep, and we'd be happy to try and help you with what your project is, and trying to help you with your vision for your IDE in the future. With that, I'm Brian Scouten, and I thank you for attending the webinar today. I appreciate your attendance, and again, if you've got any questions or comments or just want to chat, please reach out and be happy to start talking. Thanks.